Every now and then, an invention comes along so elegant and profound that it allows for the creation of technology that can make up for our biological shortcomings. These inventions come to fruition after years of testing and developing little iterations, each having the power to push society past technological roadblocks, some of which could otherwise prove catastrophic.
Airbags have saved millions of lives, but we don't often give a ton of thought to how they work. We just expect that they will. What you might not expect is that airbags themselves are actually triggered on a microscopic scale. The deployment mechanism is a one-time use, large device, but the trigger is actually a MEMS accelerometer that can detect if your car is decelerating much faster than what you'd expect driving, as might happen in a crash.
Micro-electromechanical systems, or MEMS, are machines so tiny we almost never notice them. MEMS is used in any gadget that responds to physical movement. The invention of MEMS and the various little iterations that decrease their size led to a surplus of new products and possibilities.
Think of it like a microscopic switch that's built right onto the airbag's control chip. The accelerometer physically moves with the impact and triggers the airbag to save your life. Thousands of engineers have contributed little things, little changes, that created large leaps in possibility and accessibility.
In 1959, American theoretical physicist Richard P. Feynman offered a $1,000 prize to the first person to make an electrical motor that could fit on a 1/64 of an inch cube. This same year, research and development led to the IC chip and MOSFET, which together enabled the miniaturization of electronics. And by 1960, William McClellan brought forward an electric motor only 15 1/1000th of an inch in diameter. But it was not until 1991 that an accelerometer was created for airbag systems by integrating both the mechanical and electric portions onto one chip.
Unlike most electronic components, they actually take a physical stimulus, sound, motion, pressure, temperature, etc., and translate that into a signal that electronics can understand. To test these MEMS devices, engineers need to generate some known acceleration on the device and read out the values that the device records over the course of that movement. Airbags simply can't fail. Without testing, there would be no way to safely enable product performance. Every little development and refinement of these chips allows for the creation of life-saving products that can solve previously unsolvable problems. For so much of history, we've only talked about those once-a-century breakthroughs that few people could ever hope to replicate. But that's not the only path to large-scale change.
The truth is, you can make tomorrow just a little bit smarter, or safer, or healthier, or just outright better for people. By taking part in this unending path of technological evolution, of figuring out how to make technology work a little better, every little contribution, every little thing makes a big difference.